Welcome to The Explainer. Today, we are tearing into the fascinating chemistry of hydrocarbon combustion, piecing together the clues from some really comprehensive lab materials and research.
So let's kick things off with a super simple everyday question. When you burn a hydrocarbon, like lighting a nice wax candle on your dining table or firing up a methane gas burner in a lab, where does the physical material actually go? Seriously, it just seems to vanish right into thin air, doesn't it?
Well, to solve this little mystery, we have to realize that burning fuel doesn't actually destroy the matter. Not at all. It just transforms it. You see, hydrocarbon combustion is an exothermic chemical reaction. That means a compound made entirely of carbon and hydrogen burns in the presence of oxygen, and instead of just disappearing, it turns into completely invisible gases, all while releasing a ton of energy as heat and light.
Section 1. The chemical spark. Microreactions.
Now, what's really cool is how the research perfectly balances this chemical equation for us. Look at the reactants. You take methane, which is just one carbon atom and 4 hydrogen atoms, and you add oxygen. The second a spark is introduced, boom, they rapidly react to yield the products: carbon dioxide, water vapor, and energy. Every single atom is accounted for. They've just been perfectly reshuffled into invisible gases.
Section 2. Combustion setup, experiment apparatus.
And this perfectly illustrates our trap. The lab instructions detail a frankly genius setup to catch these fleeing, invisible gases. It's a system that uses a filter funnel placed right over the flame, connected to sidearm boiling tubes and hooked up to a suction pump. Think of it like a chemical obstacle course, specifically designed to capture the products of combustion using special indicators.
It all builds into this step-by-step process. First up, we burn the fuel under the filter funnel. Step 2, we use that suction pump to actively drag all those rising hot fumes straight into our enclosed apparatus. Third, we force those trapped gases through a boiling tube that's submerged in a freezing ice and salt bath. And finally, step 4, we bubble whatever gases are left over right into a bottle of lime water.
Section 3. Detecting products, water, and CO2.
Our sources actually show 2 totally distinct methods for testing that colorless liquid condensing in the ice bath. The video and text materials use cobalt-2 chloride paper. It starts off pale blue, but the second water hits it, it turns this very distinct baby pink. Now on the flip side, the curriculum PDF uses anhydrous copper-2 sulfate. That's a white powder that turns a vivid blue when exposed to water. Oh, and quick safety note from the lab guidelines here, copper sulfate is harmful, so you absolutely have to handle it with care.
This specific chemical equation, pulled right from the research, shows exactly how that first test works down at the atomic level. The anhydrous blue cobalt chloride literally absorbs 6 distinct water